Hi, in this video we're going to simplify expressions, that means to make them simpler, usually shorter, by collecting like terms with different variables. Remember, to collect like terms means to take terms which are like terms, so that means they involve the same variable, we saw that in the previous video, and collect them together just means to bunch them together into one term. So for example, in this first expression, the 10x and the minus x here, they involve the same variable, the x, so we say they're like terms and we can combine them together into just one term. And remember, the way we do this is we look for like terms, ones with the same variable, and we underline them. So we've got the 10x, I'm going to underline that, and then I've got this minus x. Remember, we always want to include the plus or the minus in front of it. So don't just underline the x, underline the minus x here. And then, because these are like terms, we can collect them together. So this is going to be, well, if we have 10 lots of x and we're subtracting a lot of x, remember if there's no number in the front, we could just put a 1 there if you like. So we've got 10 lots of x and we're subtracting 1 lot of x, we would have 9 lots of x left. So that's going to be 9x. What else do we have? We've got this y term here. We include the plus in front of it. So we've got plus 3y. And then what other y terms have we got? Well, we've got this minus y at the end. So if we have 3 lots of y, we subtract a lot of y, 1 lot of y, we're going to have 2 lots of y left. So we've collected the y terms together. So we said there was 2 lots of y, so it's going to be plus 2y like that. And that is the final answer here. Right, what about the second one? Let's think about like terms. This first term here is 5. And notice that doesn't involve a letter. It doesn't involve a variable. We say that's a constant term. Let me just label that. This is known as a constant term. And constant terms can only collect with other constant terms. Now, there's no other constant term. There's no other term here which just has a number and no letter in it, no variable. So this 5 is just going to stay on its own. So in the answer, we're just going to put 5. There's no like terms we can collect it with. What about x terms? Well, I can see the minus x here. And I've also got the plus 4x. Remember, we should always include the symbol on the front, the plus or the minus. So minus x plus 4x. And then let's think, if we've got minus 1 lot of x, remember, if there's no number there, I can put a 1 there. If we've got minus 1 lot of x and we add 4 lots of x, well, what's minus 1 plus 4? Well, it's 3, isn't it? It's positive 3. So we've got 3 lots of x. So it's going to be plus 3x. And that's going to be the final answer there again. What about the last one? Well, the first term here is an m term. So we've got an m term, 8m. Is there another m term? No, there isn't. So we've just got 8m in our answer. Is there an n term? Yeah, we've got this minus n, and then we've got minus 3n at the end. So if we have minus 1, let's put a 1 there, minus 1 lot of n, and we subtract 3 lots of n, negative 1, subtract 3, that's minus 4. So we're going to have minus 4n. I've run out of space, so let's kind of put it on the line below. So we've got 8m minus 4n. And then finally, we've got this constant term, this term without a letter, without a variable in it. And there's nothing that collects with, so you're just left with that plus 4. And that is the final answer.